Here's another question too, from Newton application. Okay, right. It says dynamic trolley A of mass of 5 kg placed on a horizontal board. It connected with the block B of mass of 2 kg by light intangible string over a frictionless pulley shown in the diagram below. Ignore the effect of air resistance. Guys, this is a system. One thing that you need to note about system is that they have a tension force between the two. So that tension force there, that tension force is 1. So the tension force that is experienced by 5 kg, it's going in that direction, and the tension force that is experienced by 2 kg is going in that direction, and they are equivalent, those tension force. And also this system, if it accelerates, let's say we're told it accelerates in this direction, so their acceleration, the acceleration of 5 kg is equivalent to the acceleration of 2 kg. Remember guys, another thing that is important here, the one that has the frictional force is this one. If you are told it has the frictional force it applies there. The frictional force is between the tires and the surface there. And the one that has the normal force is the one that is on top of the table. So this one, it has the frictional force. If it has, if we are told in the statement, this is the one that has the normal force as well. So the one that is suspended, the one that is hanging, it has no normal force because it's not on the surface. It has no frictional force, so it will have the tension force and the gravitational force, right? Okay, let's continue. Now the first question, it says state Newton's first law, Newton's second law. All right, assume no frictional force X between the wheels of the trolley and the surface. Okay guys, before we calculate, we do 2.2.1, we calculate, let's draw the free body diagram of what, of A, which is the 5 kg. The free body diagram of that, there is the object, the trolley, the normal force, the gravitational force, and then you have what, tension there. Remember guys, there will be no friction here because we are told assume no frictional force X between the wheels of the trolley. And then the object B, the one that is hanging, the free body diagram. Guys, it's important to draw the free body diagram because it helps you in calculation. We have a tension force there that is going upwards, and then we have a gravitational force there that is going downwards. Right, now let's calculate. It says calculate the magnitude of an acceleration. Guys, in this question here, we will do what we call, it's a simultaneous equation. When they are looking for an acceleration, guys, with no tension, given the friction or no friction, that means you do it simultaneously. So you create equations there. So in 2.2.1, you will say for 5 kg, I'll start creating equation for 5 kg while I'm doing the simultaneous. Set F net is equal to ma, right? Then what are the forces that are acting on 5 kg that are involved in the movement? Is the tension only, right? So it's the tension. And guys, since it's moving in this direction, I forgot this, you need to choose that direction. So the system is accelerating this way, and you choose right down as what, as positive. So the tension equal to ma, and then we don't have a tension, equal to the mass is what, is 5a, and then that's all we have. That's equation 1. And then let's go to the 2 kg, the equation 2. F net is equal to ma. Then what are the forces that are acting on this movement? These are the forces that are acting on this one, the one that is suspended there. So the tension force is going upwards, it's going to be negative, and the Fg it's going to be downwards, it's positive, equal to MA. Then the tension force there is going to be negative T plus mg. The mass there, it's 2 times 9.8 is equal to, what is our mass there? It's 2 times A, and the acceleration. Then it's going to be negative T plus 19.6. 2 times 9.8 is 19.6 is equal to 2A. We can say that is equation 2. So what are we going to do now? We're going to substitute equation 1 into equation 2. Alright, we're going to substitute this into this. So T is equal to that. So in every T here, we're going to substitute 5A. So it's going to be here, it's going to be negative 5A plus 19.6 equal to 2A. Right? So what are we going to have? It's going to be 19.6. When we transpose this to that side, it's going to be 7A. So when we divide 19.6 by 7, it's going to be 2.8. So the answer here, it's going to be what? 2.8 meter per second square. That's the acceleration of the system. So we're done with 2.2.1. Now 2.2.2, we wanted the tension of the string. Whatever we want the tension, guys, of the string, we need to get the acceleration. Now that we have the acceleration, we can have the tension. So the tension, you substitute the acceleration. It's 2.2.2. We use the first equation, which is this. So we'll say T is equal to 5A, and then we sub the acceleration, which is what? 2.8 meter per second square. So it's going to be T is equal to 5, 2.8 times 2.8 is equal to 40 newtons. So the tension between the two is what? Is 40 newtons, the tensile force there. Right? Now, guys, that was a theoretical thing from what we are given. Now, guys, here's a statement now. It says, experimental results however showed that the actual acceleration of the trolley was 2 meters per second. The one that we calculated, it's a theoretical, right? But now the actual one, the one that is done experimentally, it's 2. So now it says calculate the magnitude of frictional force. Now experimentally, there is the frictional force. So we'll now calculate the frictional force with the new acceleration. That means with the new acceleration, there will be a new tension. So the tension we do not have, we are not given. So in 2.3, this is what we're going to have. Guys, we're not going to use this tension here. So for 5 kg, we're using the simultaneous as well. Fnet is equal to MA. Fnet is equal to MA. Remember the acceleration we're given now. So the forces that are acting on 5 kg, they're still the same. But we have the friction now. So we have a new thing. We have the friction there. So we have two forces there. We have negative Fk plus T is equal to, why did I draw them that far? Why did I write them that far? Okay, let me put it here. Okay, so we have equal to MA, and then the frictional force is the one that we want, and the tension force we do not have. Okay, we do not have both. T is equal to, the acceleration is 5, and then the mass is 5 and the acceleration is 2, so it's going to be 10. So we can have T is equal to 10 plus Fk. We'll say that's equation 1, right? So we create equation 2 by 2 kg. by 2 kg, the one that is suspended. So F net is equal to ma. Remember, the acceleration of 2 kg is still the same. So we have the negative tension plus Fg. Guys, what you need to bear in mind here, when you have a tension force that is positive for the first equation, in the second equation your tension force needs to be negative. They can't be the same sign, which is positive positive or negative negative. It has to be opposite signs, which is negative and positive. So is equal to ma there. The tension force we do not have, and the Fg is going to be the mass there. It's 2 times 9.8, the mass times gravitational acceleration, and then the mass, it's 2, the acceleration, it's what? It's 2. So it's going to be negative t plus 19.6 equal to 2 times 2 is what? It's 4. And then what are we going to have here? It's going to be negative t equal to, when you transpose this to this side, it's going to be 19.6. okay, let me just say it's going to be negative 15.4, and then our t is equal to 15.4 newtons when they both divide by okay, let me not put the newton when you divide by negative. So that's equation 2, and then we sub equation 1 into equation 2. So we're going to substitute equation 2 into equation 1. So this is going to be what? So what are we going to do? We'll have 15.4 equal to 10 plus Fk, and then this will go to that side. So your Fk will be 5.4 newtons. Okay guys, the last part of the question, which is 2.4. Now it says the trolley is modified to eliminate the effects of friction. So by saying to eliminate the effect of friction, that means there's no friction. Friction is removed there. Now it says the pulley ends of the board. The pulley end of the board is now raised so that it makes an angle theta with a horizontal. Guys, if you see the difference between this and this, now the 5 kg is on an inclined surface, but there's still a pulley, but the pulley now is raised, and the object B is suspended. Okay, now the question, it says calculate the value of angle theta so that the trolley remains at rest. Okay, we wanted that angle there. Okay, let's cut the chase, guys, in 2.4. Let's do it in 2.4. Guys, what do you need to understand there? Forces that are acting here, it's Fg parallel, no frictional force, normal force, gravitational force, tension force there, gravitational force. Those are the things that you need to remember there. Okay, let's do an okay. Guys, here's another thing that is important. It says calculate the value of an angle theta so that the trolley remain at rest. So that means this trolley is at what? It's at rest. That means the acceleration is what? Is 0. So the trolley is at rest, but we want this angle. So it's very important that. So we'll say F net is equal to 0 because it's at rest. So what are the forces? Okay, this, well, I like to label. This is 5 kg equation. So F net is equal to ma, and then acceleration is 0. So we have the F net is equal to 0 there. And then whether the forces are acting on 5 kg, and then if we choose this direction as positive, right? That direction is positive, so we will have the tension force will be what? Positive there, and the FG parallel is going down the slope will be negative, equal to 0. So tension force is equal to FG parallel. They're equivalent. So the tension force is equal to mg sine theta. What is our mass there? It's the 5 times g, which is 9.8 sine theta. We are looking for this theta. So T is equal to that. We'll say that is equation 1. Now let's create equation 2 by 2 kg. We'll say F net is equal to 0. What are the forces that are acting there? The gravitational forces, it's going downwards, it's positive because we chose that direction. So Fg is positive minus the tension force. Remember what I've spoken about, that the tension force needs to be negative. Negative and positive. This one is positive, this one it will be negative. So equal to 0. So there the Fg is equal to the tension force, if you're paying attention to that. So T is equal to mg, right? Twisted them, and then T is equal to 2 times 9.8, which is 19.6 T. That's equation 2. And then we have equation 1 and equation 2. So we're going to sub this into T there. So we're going to have 19.6 is equal to 5 times 9.8 sine theta. So we divide by 5 times 9.8 sine theta. No. So we're going to divide by 5 times 9.8 both, and then 5 times 9.8 both sides, and then we'll have sine theta is equal to this answer here. But when I want the angle here, it's going to be angle is equal to second function sine. It's going to be 19.6 divided by 5 times 9.8, which is the theta. It's going to be, when you punch that in the calculator, it will be 23.58 degrees. That's the end of the question.